Good evening, students. Welcome to Shruti Academy. So let us start with the two important terminologies of the SCR silicon control rectifier, which are the latching current and the holding current. Okay. So latching current is associated with the turn on process and holding current is associated with the turn off process of the SCR. So let us discuss today about what is the latching current. Okay. So it is the minimum anode current which the SCR may attain during turn on process to maintain conduction when the gate signal is removed. Okay. So when the gate signal is removed, in order to maintain the conduction, it is that minimum anode to cathode current. It is that minimum anode current, that minimum anode to cathode current. So we can write over here IAH should be greater than equal to IL. Okay, it is that minimum anode to cathode current, which could maintain the conduction even when the gate signal is removed. Okay, so it is associated with the turn on process. In order to turn on, the minimum amount of anode to cathode current required so that the SCR may operate in the turn on condition mode. Okay, turn on mode. So concept of latching current is used for determining the minimum gate pulse width required for the turn on the SCR. So the concept of latching current is very much important also for the determination of the minimum gate pulse, that how much gate pulse should be given, minimum gate pulse required for the turn on the SCR. So we already know when the SCR is in the forward blocking mode, how it is turned on. It is turned on either of the two ways. One way is that if we make our voltage above the breakover voltage, or we give the voltage source to the circuit that is above the voltage breakover voltage, then the junction J2 breaks and eventually the current starts flowing. One way is this, and the other way is through triggering the gate pulse. So latching current is very much important for determining the minimum gate pulse width required for the turn on the SCR. So how much minimum gate pulse width we should give to the SCR so that the SCR may get turned on. Okay, so if we see it is positive pulse, we can draw the positive pulse over here. So how much that pulse should be given to the SCR? Okay, so this is the T gate IG, T minimum, and it is calculated in microseconds. Okay, so how much that pulse width should be given, to the circuit so that my SCR gets turned on. Okay, so this is important factor related to the latching current, an important point to be noted. Then the second current is the holding current. Let us first look where the latching current will be depicted in the VI characteristics of the SCR. So here is the latching current. So it is the minimum amount of current and beyond which the SCR is in the turn on state. So it is the minimum amount of current. It is depicted over here. This is the latching current. Okay. So now let us discuss about the holding current. So holding current is the minimum value of the current below which the anode current must fall to come in the off state. So this is the holding current depicted over here. Below this holding current, the SCR will be in the off state. Below this holding current, the SCR will be in the off state, and beyond this latching current, SCR will be in the on state. Okay, so it is associated with the turn off process of the SCR. So it is associated with the turn off process of the SCR. So we can write over here IA case should be less than IH. Okay, for the turn off process. Now these are the two conditions which we know. If anyhow we do IAK less than IL and anyhow IAK greater than IH, then what will happen? When the anode to cathode current is greater than latching current, that means latching current is the minimum current to keep the SCR, maintain the SCR in the on state. If the latching current becomes greater, then that condition cannot be determined. This condition is for the on state, but this condition cannot be determined. So we are going to write over here simply cannot be determined. Okay, and similarly this condition is for the off state, when the turn off process, if it is the minimum, it is that current which is required to beyond which it is required for the off state, and if we increase our anode to cathode current greater than the holding current, then this condition cannot be determined. Okay. So the holding current is the minimum value of the current below which the anode current must fall to come in the off state. So it is associated with the turn off process. So current must fall below which if we make our current below the holding current, then our thyristor will come in the off state. But if our current is greater than the holding current, that case we cannot determine the actual state of our SCR. So this was all about the concept of the holding current and the latching current. So thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.